Assalamualaikum warahmatullahi wabarakatuh. Today, we want to present our group project for ISP 610. The topic is Sentiment Analysis and Classifier Model of ASAP Ticket Review. Before we start our presentation, I would like to introduce our team members. Firstly, myself, Muhammad AZRY bin SHAIFUDDIN. Second, AMIRUL ID bin ITHNIN. And last, SITI SOFIYYAH binti SAMSUL. ASAP Ticket is a United States-based online travel agency founded in 2001 by Alex Winston. The company helps people book airline tickets, especially for international travel, and often offer cheaper or unpublished price. ASAP Ticket use real travel agents who help customers find flights, make booking, cancellation, and it operates worldwide with multilingual support. In this project, to better understand how ASAP Ticket service are perceived by customers and to evaluate overall customer satisfaction, more than 1,000 user reviews including name, location, date and rating that we have collected from Trustpilot website. We use RAFIQUE to process and classify the text data and use W to visualize the result. The problem statement of this study focuses on the difficulty of understanding customer feedback for ASAP Ticket due to unorganized and large amount of online review, which lead to the following issues. First, unclear customer opinion. Reviews are mixed and hard to understand without analysis. Second, no summary of overall sentiment. There is no clear overall view of how customers feel about ASAP tickets. And last, large data is hard to analyze manually. Reading and interpreting more than 1,000 reviews manually takes a lot of time and inefficient. Moving on to the next part, the objective of this study based on descriptive analytics and predictive analytics. For descriptive analytics, to describe the customer review data of ASAP tickets from Trustpilot and to summarize the overall customer sentiment, whether it's positive or negative. For predictive analytics, to build a model that predicts the sentiment of review based on the text content and to evaluate the prediction model's performance and accuracy in classifying customer opinions.
Now, I will explain the methodology used in this study. For this project, our methodology used focused to understand the customer satisfaction based on the online reviews of the ASAP tickets. The main goal here is to determine whether the customers are generally happy or unhappy with the service that we have provided. First, from a business understanding perspective, sentiment analysis helps us by supporting the decision making. By analyzing the customer's review, future users and researchers can better understand the service quality of the ASAP tickets before deciding to use the platform. Instead of relying the random opinions, this approach provides us data-driven insights. In terms of data understanding, we collected almost 1,040 customers' reviews from the Trustpilot, which is a trusted and widely used in a review platform. This ensures that the data source is reliable and reflects real customers' experience. The dataset contains several important features such as customer name, location, rating, review text, and a date. These attributes are crucial because they allow us to analyze the feedback patterns, identify statement trends, and understand how customer opinions change over the time. Moving on to the data description. These slides explain the main attributes used in our dataset. Each attribute plays an important role in sentiment analysis. The name attribute represents the user who posted the review. The location shows the country or a place of the reviewer, which helps us understand the geographical patterns. The rating is the star rating given by the customers, usually ranging from the 1 to 5, indicating their level of satisfaction. The review is the textual feedback written by the customers, and this is the most important attribute for the sentiment analysis. Lastly, the data shows when the review was posted, which allows us to analyze the sentiment trends over the time. Finally, this slide shows the data dictionary. The data dictionary explains the type and the level of measurement for each attribute in the data set. For example, attributes like a name and location are categorical and measured at a nominal level. The rating attribute ordinal because it represents the order values. The review attribute is qualitative text data, which is processed for sentiment classification. Meanwhile, the date attribute is quantitative and measured at an interval level. For the data preparation, I will show how scraping is performed using the real website, which is Trustpilot. The company used in this example is ASAP Tickets. Web scraping is a method used to automatically collect data from the websites. In this presentation, I will show the step by how the customer's reviews are extracted using a Chrome extension called Instant Data Scraper. This slide shows the Trustpilot page for the ASAP tickets. Before scraping, it is very important to understand the structures of the website. Here we can see the overall rating, the number of the reviews, and a summary of the customer feedback. However, this section only shows us the summarization of the information. To collect the detailed data, we must go to the All Reviews section. In this step, we prepare the scraping tool. I am using the Google Chrome and I open the extension menu. From there, I select Instant Data Scraper. This tool is suitable for the beginners because it can automatically detect the structure of the data, such as review lists without the coding. Before scraping, we must clearly identify what data we want to collect. In this case, each review contains the reviewer's name, location, star rating, review text, and the review date. These elements are repeated before every review, which makes them suitable for the web scraping. After reaching the All Reviews page, I open the Instant Data Scraper. Then the tool will automatically detect the review structure and displays the preview of the data in rows and columns. This preview allows us to confirm that the correct data is being captured before the scraping begins. Since Trustpilot reviews are spread across multiple pages, we must enable the page navigation. By clicking the Locate Next button, we teach the scraper how to move from the one page to the next. The tool then crawls multiple pages automatically and collects the review. We can monitor the number of the pages scraped and rows collected in the real time. Once enough reviews are collected, the scraping process will be stopped. The data can then be exported as a CSV or Excel file.
For the data transformation process, several important steps were applied. First, convert text to lowercase, standardize text so words are consistent. This step helps ensure that the same words are treated equally during analysis. The example can see in the slide. Next, tokenize sentence into words. Breaks review into individual words for easier analysis. By separating sentence into single words, the system can analyze patterns and frequency more effectively. The example also can see in the slide. Finally, stemming or lemmatization. Reduce word to root form for analysis. This step help group similar words together so the meaning is clear and more accurate. Example, traveling to travel. For the data aggregation process, the data is summarized to make the result easier to understand. First, group review by sentiment, whether positive or negative. Organize review into category based on labels for easier analysis. This allows us to clearly separate customer opinion into meaningful groups. Next, count review in each category. This step help identify the overall trend of customer sentiment toward ASAP ticket. Example, from 10 review, 9 positive and 1 negative. This make it easier to compare and interpret the result. Data cleansing process. The data is cleaned to improve accuracy and reliability of the analysis. First, remove duplicates and irrelevant data. Prevent repeated or unrelated reviews from biasing result. This ensures that only meaningful and valid reviews are used in the analysis. Next, handle missing or empty entries. Avoid errors from reviews with no text or missing rating. This step helps maintain consistency and prevent issues during processing. Finally, clean special character, typos, and unnecessary words. Standardize text for easy analysis. By cleaning the text, the data become more structured and suitable for further processing. For the data tagging process, the reviews are labeled automatically to make analysis faster and more accurate. First, tag reviews automatically. Instead of manually reading hundreds of thousands of reviews, the system applies rules or models to assign label. This saves a lot of time and ensure consistency. Next, label positive and negative. Categorize the overall sentiment of each review. By labeling reviews, we can easily see how customers feel about ASAP tickets. Finally, text keyword or topic. Important words or praise are identified to understand trend. This helps highlight the most discussed aspect of the service and give a clear picture of customer feedback.
Okay, now we move to the data quality. Okay, this process is one to scoring the data. First, we need to load the data. Load the clean data review into the rapid miner. The second step is we using the replacing missing value. This operator want to replace every missing value with the constant value. The third step is nominal to text. This operator is to convert the nominal attribute into text. The step 4 is to extract sentiment. This is the important operator because this operator is to give a score on text data. And lastly, like Excel is we want to save the file Excel in the Excel file.
For the first objective of our exploratory data analysis, we focus on the analyzing the customer satisfaction based on the rating, frequency using the table view visualizations. The pie chart presented here illustrates the distribution of the customer's rating for ASAP tickets, ranging from the 1-star to 5-star reviews. This visualization allows us to quickly understand how customers evaluate their overall experience within the service. From the chart, we can clearly observe that the majority of the customers provide a 5-star rating, which represent a highly positive sentiment. In contrast, only a very small percentage of customers gave low ratings such as 1 star or 2 stars, indicating the minimal negative sentiment within the dataset. For this part, we analyze customer ratings using a frequency table to understand the overall sentiment distribution of the customer feedback. The table represented here shows the frequency of customers rating for ASAP tickets categorized from 1 star to 5 star. This table allows us to observe the exact number of the reviews for each rating level, which provides a clear quantitative overview of customer satisfaction. From the table, we can observe that the highest frequency comes from the 5-star ratings, with a total of 956 reviews. This indicates that the majority of the customers express a highly positive sentiment towards ASAP tickets. In comparison, 4-star ratings appear much less frequently, and ratings of 1 star, 2 stars, and 3 stars represents only a very small portion of the dataset. These low-frequency ratings indicate that the negative and neutral sentiments are minimal among customers. For the next exploratory data analysis, we analyze the distribution of the customer's review over the time based on the review date. This analysis helps us understand how customer feedback activity changed across the different months. The area chart represented here shows the monthly count of the customer's review for the ASAP ticket. Each data point represents the total number of reviews recorded in a particular month. These visualizations allows us to observe the temporal trends in customer engagement and feedback behavior. From the chart, we can observe that the number of the reviews remains relatively low during the earlier months. However, there is a significant increases in the number of the reviews starting from the October 2025, followed a sharp peak in the November of 2025. This indicates a surge in the customer feedback activity during this period. The sharp increase in review volume suggests higher customers' interaction with the service, which may be associated with the peak travel seasons or increased service usage. During such a periods, customer sentiment, whether the positive or negative, becomes more visible due to the high volume of the reviews. After the November 2025, the number of the reviews decreased again in December 2025, indicating that a reduction of an in-feedback activity. This fluctuation highlights how customer sentiment expressions varies over the time rather than remaining constant. Finally, the last data analysis will examine the geographical distribution of the customer's review to understand how the customer sentiment is represented across the different regions. This map visualization shows here illustrate the number of the customers' reviews by the country. The darker color shades indicate the countries with a higher concentration of the reviews, while the lighter shades represent the lower review counts. This visualization helps us to identify which regions contributes most to overall customer feedback dataset. From the map, we can observe that the majority of the customer reviews originate from the United States, followed by the Canada. These regions shows that the highest review density indicate that the customer feedback and sentiment in the dataset are largely dominated by the users from the North America. In contrast, the other regions display that the significantly fewer reviews, suggesting that the lower customer participation or engagement in providing the feedback. As a result, the overall sentiment trends observed in this study are more reflective of the customer's experience in regions with the higher review volumes.
Okay, this all operator is using in this process to make a predictive data. This is just a general. Okay, first we need to retrieve and prepare the training data. Okay, the second we need to select the attribute, which is the class and review. And we need to set the label in the set role, which we label the class. Okay, after that, we need to convert the nominal to text and process the document. After we process the document, we need to train and evaluate in the cross validation. After that, we using apply model to test data. And lastly, we save the data result in the Excel. Okay, this is a detail in this predictive data. Okay, first we need to load the training data set into the RAFIQUE miner. Second, we select the attribute. We just keep only relevant attributes like class and review only, and we remove unnecessary columns. Okay. The third step is using the set rule. We set the class as a label. The step 4, nominal to text. We convert text attribute from nominal to text. The step 5, we using the operator process document from data. In this process, we convert text into numerical feature. Inside the process document from data, we have tokenized operator. Tokenized we using is to split text into individual word. Uh, Transform case, we convert all text to the lower case or uppercase. And filter stop word, we remove common words such as the, is, are, and, of, to, because this word do not add meaning for classification. And stem potter. Stem potter is using to convert words to their root form. Okay, now I will talk about the detail in the cross validation operator. We divide the dataset into multiple fold to reduce the overfitting and improving their reliability. Okay, in this cross validation, we use three model. First, navy bias. Second, support vector machine. Third, gradient boosted tree. The train model is then passed to the apply model operator in the testing subprocess. The model is applied to the test data to generate predicted label for unseen instance, and we use the performance operator to evaluate the predicted result. Performance metrics such as accuracy, precision, recall, and confusion metric. Okay, this for the testing data. We need to load the testing data into the rapid miner. The second, we need to convert the nominal to text. The third, we need the process document data. It's same like above. We need in the process document data, we have tokenized transform cases, filter stop word, and stamp potter. After that, we apply into the apply model. And lastly, we save the file into the Excel. After we do the rechecking file for the testing data and the predictive data in the file Excel, we can see there are some false prediction. The true negative should be for reviews only, neutral 8 reviews, and the false negative 12 reviews. So neutral and false negative should be a positive review. So we calculate the percentage for the false predict, we get 83.33%. This is the result of three performance model with navy bias, support machine, and the gradient boosted tree. Okay, this is the comparison between three model for the accuracy, precision, and specificity. So the best model we choose is navy bias because the accuracy is 92.58%, able to do prediction on classification correctly, and the precision 99.70%, accuracy positive prediction. And last one, the specificity 71.43% correctly identify negative cases. So as we can see, this is balanced in positive prediction and negative cases. Lastly, for the conclusion, for the data collection and focus, we collect almost 1,040 reviews from web scraping from Accept Ticket website. The study analyze and visually accept ticket customer review automatically. Descriptive for the descriptive analytic, the data show that Accept Ticket had become very popular in November 2025 with many people sharing their experience with with writing the review. But in the next month, the review was declined. So the majority the customer from United States and Canada who give the review from this website. And for the predictive analytic, we predict analytic to categorize review into positive and negative review. We did develop a classification model to accurately categorize the review by using three model: Navy Bayes, support by the machine, and gradient boosted tree. And the best model is Navy Bayes. So for the significance study, the finding help asset decade to make an improvement addressing customer review and fit their service to be a better service.
That's all from us. Thank you.